Good morning, Satish. Are you getting my voice? Where are the remaining people? Satish, are you getting my voice? Hello? 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 Satish?
Good morning, sir. Sir, good morning, sir. Voice break అవుతుంది సార్.
My friends ఎవరు రాలేదండి, ఒక్కరే జాయిన్ అయ్యే క్లాస్. వాట్ అబౌట్ ద రిమైనింగ్ పీపుల్? సతీష్,
Satish, ఇప్పుడు వస్తుందా వాయిస్? హలో? హలో? వాయిస్ వస్తుందా ఇప్పుడు? ఇప్పుడు వస్తున్న వాయిస్ ఓకేనా ఇప్పుడు? హలో? హలో సతీష్? Hello. Okay, good morning, guys. Today we are going to discuss one more important concept that is called the buffering technique. Okay, what is this buffering technique in the operating system? What it will do? So before going to know what is this buffering technique, we have to know what is a buffer. We have to clearly know what is a buffer. What is a buffer means? A buffer is a temporary memory, temporary storage memory. Okay, a buffer is a temporary memory for storing data. It can be called as a buffer, can be called as a temporary storage or temporary memory. That means in the temporary memory, we will store the data for some temporary period of time. We can store the data in that buffer. That is the thing. What is a buffer means? A buffer is a temporary storage device. It's clear now. A buffer is a temporary storage device. That's okay. What is this concept of this buffering? Why we have to use the buffer to store the data temporarily? Why we need to use the buffer? That is the concept here. So to understand this one, why we need the buffering, we have to know one point is, generally we know very well, when we come to the structure of the computer, it has input devices will be there, CPU will be there, output devices will be there. The CPU will take input from the input devices, it will process the data, and the output data will be given to the output devices. It will take input data from input devices. After processing that input data, it will produce the output data, and the produced output data will be transferred to the output device. That means data is moving from input device to CPU, CPU to output device. The data is moving between these three: input or output devices to CPU, CPU to input and output devices. I/O communication, we call it as I/O communication. From input or output devices, the data from input device, the data is moving to CPU. From CPU, the data is going to the output devices. But the small problem here is the speed of CPU and speed of I/O devices are not same. The speed of CPU and speed of I/O devices are not same. Generally, the speed of I/O devices are somewhat less when we compare with the speed of CPU. There is a speed mismatch between these I/O devices and the CPU. What's the problem when there is a speed mismatch between I/O devices and CPU? What will happen? What is the problem? Then, for example, if you take a general example, okay, we can take one example, that is, for example, okay, we are taking some books from our friend. We are taking some, for example, take the cricket balls. We know we will play the catches. Okay, one person is throwing a ball, the other person will catch that ball. Okay, two persons. The ball is moving from person one to person two. Balls are moving. Here, what will happen is, if one person is fastly throwing the balls, what will happen? Since there is one person is fastly throwing the balls, but the other person is not that much fast to receive the balls, then what will happen? Person A is fastly throwing the balls, but person 2 is not that much faster to catch all those balls. Then what will happen? Some balls will be missed. Okay. Why? Because since the two persons are not with the same speed, the problem is some balls are going to be missed. For example, person A is throwing the balls, person 2B is receiving the balls. If the speed of person A is faster than the speed of person B, person A is more faster than the person B, what will happen? Person A will throw the balls fastly. Since person B is somewhat slow when we compare with person A, he will miss the some balls. He will catch first ball. While he is catching first ball, second ball will come. He will miss the second ball. He will catch the third ball. While he is catching the third ball, he will miss the fourth ball. Like that, some balls will be missed. Vice versa. If the speed of person A is less than the speed of person B, what will happen? Person A will throw throw the balls very slowly, so that person B has to wait for more time to receive the balls. He will receive first ball, he will catch the first ball, and he has to wait for some time to receive the second ball. Why? Because person B is faster, immediately he is receiving the ball, but person A is slow, he is sending the balls slowly. Okay, because of the speed mismatch, there will be a practical problems between the two persons. Same situation will come to the IO devices and CPU also. IO devices are input devices are sending data to the CPU. CPU sending output data to the output devices. Okay, since the speed mismatch is there between the IO devices and CPU, okay, the problem means some data will be missed here. There is a chance of missing of the data. Now, since there is a speed mismatch between those two, what we have to do? How to solve this problem of speed mismatch between the IO devices and CPU? Okay, that's to solve the problem of speed mismatch between the IO devices and CPU. We are going to use the concept of buffering. That means between IO devices and CPU, we will place it will go to data in the from that buffer, output device will take the data from the buffer. Okay, between input devices and CPU, between output devices and CPU, buffers will be placed. So that what will happen, since there is speed mismatch between the two persons, input IO devices and the CPU, to resolve the problem of speed mismatch, in the middle we are placing the buffer. Whenever IO devices have data, they will place the data in the buffer. CPU will take the data. Similarly, whenever CPU has data, it will place the data in the buffer. IO devices will take the data. That is the concept of this buffering. With the help of this concept of buffering, the problem of speed mismatch between the IO devices and the CPU is resolved. Okay, see this one once. What are the points in this buffering concept? Simply, again, we will get the same concept in CO also. Buffer concept will come in CO also. Computer organization subject also. What is a buffer means? A buffer is a temporary storage. See the first point. The buffering technique is used to reduce the difference in speed between IO devices and CPU. To reduce that speed difference between IO devices and the CPU, this buffering technique is used. Clear? The buffering technique is used to reduce the speed difference between the IO devices and the CPU. The input-output devices are generally electromechanical devices. The IO devices, that means your keyboard, mouse, or printer, monitor, all these things are the input-output devices are generally electromechanical devices, and their speed is very slow when compared to the speed of CPU. The speed of IO devices are very slow when we compare with the speed of CPU. That means there is a huge speed difference between IO devices and the CPU. Okay. So to handle this mismatch in the speeds, buffering technique is introduced. To resolve this mismatch of the speeds, buffering technique was introduced. What is a buffer means? Buffer is a temporary intermediate storage area. How can we define a buffer means? A buffer is a temporary intermediate storage area. Okay, here the data will be stored only temporarily. Temporarily, the data will be stored in this one. That's why a buffer is a temporary intermediate storage area. Clear? See what will happen here. When input device reads some data, the data is placed in the buffer. Whenever the input data has some data, that input data will be placed in the buffer, and after that, when the read operation is over, the data which is in buffer is transferred to the CPU at very fast rate. See this point clearly one more time. For example, from the keyboard, we are giving the input data. I am typing some text from the keyboard. I am for typing the data. So what will happen is, okay, whenever input devices are getting data, all the input data will be placed in the buffer. Okay, the input data which is given by the input devices are placed in the buffer. After that, read operation is over. That means input data read operation is over. The entire data input data which is in the buffer is transferred to the CPU at very fast rate. See, input devices will place the input data in the buffer at very slow speed, at very slow rate. Okay, after the input data is completely placed in that buffer, from that buffer, that input data is transferred to CPU at very fast rate. Clear? First, see, input devices will place the input data in the buffer. From that buffer, the data is transferred to the CPU. Similarly, if data is to be transferred to the output device, for example, CPU has some output data which is needs to be transferred to the output device. What will happen? CPU places the data in the buffer, and from buffer data will be go to the output device. Similar to the input device, CPU will place the data in the buffer, and from the buffer the data will be placed to the output device. That is what is happening in this buffering technique. See, buffering can also be used for data transmission between two devices, not only between I/O devices and CPU, between any two devices who has the speed mismatch. This buffering technique can be used. That's why I said buffering concept will also come in the computer organization subject also, not only in OS but also in computer organization subject also. Again, we will get the same buffering concept. Clear? Now see this one again. See the points. The buffering technique is used to reduce the speed difference between input output devices and the CPU. The buffering technique is used to reduce the speed difference between output devices and the CPU. Generally, the input output devices are electromechanical devices. The I/O devices are electromechanical devices, and their speed is very low when we compare with the speed of CPU. The speed of these electromechanical devices, that is I/O devices, is very low when we compare with the speed of CPU. So to handle this speed mismatch, buffering technique is introduced. To handle this speed mismatch, buffering technique was introduced. What is a buffer means? A buffer is a temporary intermediate storage area. How can we define this buffer means? This buffer is a temporary intermediate storage area. What will happen here is, whenever the I/O devices has some input data, when input device reads some data, whenever the input device reads some data, the data is placed in the buffer. And when the read operation is over, the data which is in the buffer is transferred to the CPU at very fast rate. Since CPU speed is more and input devices speed is less, the input devices will place the data in the buffer with their normal speed. After all the data is placed in the buffer, that data in the buffer will be transferred to the CPU with a very fast rate. With the speed of the CPU, the data will be transferred from buffer to the CPU. That is happening. What is happening between input device and the CPU? The same thing will also happen between output device and the CPU. Whenever CPU has data to transfer to the output device, after the processing is over, the CPU has to transfer the output data to the output device. If data is to be transferred to the output device, the CPU places the data in the buffer. The CPU places the data in the buffer, and from the buffer, data will go to the output device. The CPU places the data in the buffer, and from the buffer, data will go to the output device. That is the thing. What is happening in the buffering? Okay, this buffering can also be used between any two devices who have the speed mismatch. Not only between these two, it can be used in any two devices where we have the speed mismatch. Okay, this is the buffering technique. If it is clear, similar to buffering, one more concept is there which is similar to the buffering but with a slight difference. That is called the spooling. Another concept of which is similar to the buffering is called a spooling. It is almost similar to the buffering, but there is a difference is there. After spooling, we discuss the spooling. We will discuss what is the difference between buffering and spooling. Okay, first of all, what is this spooling? What is the full form of spool means? Spool means simultaneous peripheral operations online. SPOOL. What is the full form of this spool? S means simultaneous peripheral. Peripheral means input or output devices only. Simultaneous input or peripheral devices means input or output devices only. Operations online. Simultaneous peripheral operations online. Why it is simultaneous peripheral operation online? We will discuss that point at the end of this concept. First, we will briefly see what is spooling. Here also this concept is similar to that of buffering. Okay, between the IO device and the CPU, buffer will be maintained here also. See, here also the concept is in a spooling, more than one IO operations can be performed simultaneously. That is at the same time. When CPU is executing some processes, then more than one IO operation can also be done at the same time. See, what is the spooling concept is? It is similar to the buffering, but the difference is buffering concept is used for single job only. When there is only one job executing in the system, when only one job is running in the system, buffering concept is used. But when we come to the multi-processor systems, already in the yesterday class we have discussed the multi-processor systems. What is this multi-processor systems? Multiple jobs are running simultaneously. For example, job J1, J2, J3, three jobs are running parallelly. So J1, for J1, input data will be there, output data will be there. Similarly for J2 also, input data will be there, output data will be there. For J3 also, input data will be there, output data will be there. So three CPUs are there, CPU1, CPU2, CPU3, and CPU want input data of J1. At the same time, CPU2 wants input data of J2. At the same time, CPU3 wants input data of J3. After some time, CPU1 produce output data of J1. Similarly, CPU2 produce output data of J2. Similarly, CPU3 will produce output data of J3, job J3. That means parallelly, for three jobs, it want multiple IO operations. Okay, parallelly, in this example, parallelly, three IO input data is coming. Three input operations are going on. Similarly, at the same time, parallelly, three output operations are going on. That means multiple IO operations are going on in this one. Generally, in a normal system, only one CPU will be there, and that CPU will execute only one job at a time. In a normal computer system, only one processor will be there, and it will execute only one job at any time, so that IO operation is required for only one job. Since only one job is running, IO operation is required for only one job. So for the system which will execute, which requires only one IO operation, for that type of systems, buffering technique is used. But when we come to the multi-processor systems where multiple jobs are running, multiple IO operations are required. For that system which requires multiple IO operations, we use the concept of spooling, simultaneous peripheral operations online. Simultaneous means at the same time. Peripheral means IO operations. Peripheral operations means nothing but IO operations online. That means at the same time we can perform multiple IO operations. That means we can send multiple input data at the same time. We can receive multiple output data at the same time from the CPU. That is the only difference. Remaining concept is same. See this one. So in a spooling, more than one IO operation can be performed simultaneously. More than one IO operation can be performed simultaneously. At the time when CPU is executing some process, while CPUs are executing some processes, we can perform multiple IO operations. Okay, that means one input device is sending some input data. At the same time, second input device is sending some other data. Third input device is sending third data. Like there, multiple input data will come. Similarly, multiple output data will come. One of first output data, second output data, third output data. Like that, multiple devices are sending performing multiple IO operations. To support that one, where is the concept of spooling? See this following image. Input devices, CPU, main memory is there, output devices are there. In case of spooling, what will happen is, what is the concept of this spooling is, since the system is a multi-processor, multiple IO operations are going on. Whenever multiple input data are there, all the multiple input data are first placed in some secondary storage in buffer. The multiple IO input data is placed in the buffer. Okay, the multiple input data are placed in the buffer, and whenever CPU wants the input data, it will ask the main memory, please bring the input data. Then main memory will bring that input data from a second buffer to main memory. See what will happen is, for example, three jobs are running. Input data of J1, input data of J2, input data of J3. Parallelly, input data of J1, J2, J3 are coming. Where it will place all that one, the input data of J1, J2, J3 are placed in the buffer. First, the input data of three jobs will come to the buffer. Whenever CPU requests the input data of J1, now the input data of J1 will come to main memory. If CPU requires the input data of J2, the input data of J2 will come to the main memory. If CPU requires input data of J3, the input data of J3 will come to the main memory. Similarly, the CPU will produce output data of J1, output data of J2, output data of J3. The CPU will produce the output data of J1, J2, J3. What it will do is, directly don't send the three output data to the output devices. The CPU will place the output data in the buffer. It will also place the output data in that secondary memory. In that buffer memory, it will place. Next, okay, the output device will take the output data of J1. After displaying the output data of J1, again the output device will take the output data of J2 from the buffer. After the displaying of the output data of J2, again the output device will take the output data of J3 from the buffer. Input devices will place the multiple input data in the disk. CPU, whenever the CPU wants the input data, it will take the data from the disk. Similarly, CPU will produce multiple output data, and all that multiple output data are placed in the disk. Okay, output devices will take the output data whenever they want to display. Clear? All this process is running parallelly. IO devices are continuously placing the input data in the disk. CPU is continuously taking input and producing output and place the output in the disk, and output devices are continuously receiving the data from the disk. All these three are running parallel. That's why it is called the simultaneous peripheral operations online. This concept is called simultaneous peripheral operations online. See what will happen. We can have multiple number of input devices. We can have a number of input devices at a time. So all the input devices can put the data in the disk or secondary memory. When we have more number of input devices, okay, all the input devices can put the data in the disk or secondary memory. Here we are using that secondary memory as a buffer. We are using the secondary memory as a buffer. Okay. Secondary memory as a buffer. When multiple input devices have data, all the multiple input devices can place their data in the disk or secondary memory. Then the main memory will fetch the data one by one from secondary memory, and CPU will execute some instruction on the data. Whenever CPU wants the data, the main memory will fetch, means will bring the data one by one from secondary memory, and CPU will perform some instructions on that data. Okay. While CPU is executing the some task, the input devices has no need to wait. The input devices will continuously place the data in the secondary memory. Okay, without waiting for the CPU. While CPU is executing the jobs, the input devices have no need to wait. They can continuously place the data on the secondary memory, that is buffer. Okay, in this way the CPU will be in execution phase most of the time. But the advantage of this spooling is CPU will not sit idle. Okay, while CPU is working on J1, the input data of J2 is available in the is placed in the secondary memory. So after J1 is over, immediately CPU will start the J2. While CPU is executing J2, the input data of J2 will be placed, J3 will be placed in the secondary memory. So after J2 is over, immediately J3 will be started. That is what is happening between input devices and CPU. The CPU will never sit idle in this spooling concept. See, when we have the number of input devices at a time, all the input devices can put their data in the disk or secondary memory. Okay, then the main memory will fetch the data one by one from the secondary memory, and CPU will execute some instructions on that data. Whenever the CPU wants the data, main memory will fetch the data one by one from secondary memory, and the CPU will execute some instructions on that one. Clear? When the CPU is executing some task, the input devices will bring the remaining input data into the secondary memory. In this way, the CPU will be continuously in execution phase. The CPU will be always in execution phase without waiting for the input data. Similarly, the same thing will happen between CPU and the output devices also. When CPU generates some output, then the output is first placed in the secondary memory, stored in main memory, and from main memory it will be transferred to the secondary memory. Okay, after CPU generates the output is first placed in the main memory. From main memory, it is not directly given to the output device. It will be placed in the secondary memory. Okay, from secondary memory, the output will be transferred to the output devices. Okay, by doing so also again, we are saving the time because CPU doesn't have to wait for the output devices. ఇందులో అడ్వాంటేజ్ ఏంటంటే ఇక్కడ కూడా CPU for example, if the output is not transferred to the secondary memory, if the output is in main memory, if you want to transfer the data from main memory to output device, if the output device is busy, the CPU has to wait until the data from main memory has to go to the output device. But by using this spooling concept, instead of sending the data from main memory to the output device, the data will be transferred from main memory to the secondary memory, so that immediately CPU will start executing next job. The CPU has no need to wait for the output device. That is what is happening between input devices, CPU, and the output devices. Simultaneous peripheral operations online. Clear? For example, to understand this spooling concept, best example is the printer. If you take a printer, I want to print 100 pages. So what I will do? Simply I will give the input of 100 pages to take print out. 100 pages print చేయాలి కాబట్టి I will press Control P. కీబోర్డ్ లో Control P ప్రెస్ చేశాను. వార్డ్ డాక్యుమెంట్ లో 100 pages ప్రింట్ చేయమని ఇన్పుట్ డేటా ఇచ్చేసాను. I have given 100 pages input data to the CPU. ఇప్పుడు CPU ఏం చేస్తుంది? ఫస్ట్ టేక్ పేజ్ 1. ఆఫ్టర్ ప్రింటింగ్ పేజ్ 1, CPU will take పేజ్ 2, పేజ్ 3, 1 by 1 తీసుకోవాలి. కానీ నేను వరుసగా ఏం చేస్తున్నాను? 100 pages ఇస్తూ ఉన్నాను. మన 100 pages ఇచ్చినా కానీ CPU ఎన్ని పేజెస్ ప్రింట్ చేస్తుంది ఎట్ ఏ టైం? It will print only 1 page at a time. So, but remaining, what will happen? Whenever we are giving the 100 pages of input data, first all that 100 pages of input data will be sent to stored in the secondary memory. Okay, after storing that 100 pages of data in the secondary memory, every time CPU will take 1 page. First CPU will take first page, and it will send that first page to it will take first page, next it will take second page, next it will take third page, like that. Again, what will happen is, after CPU taking that page 1, it has to send that page to the printer. CPU has to send the first page to printer. So CPU has to wait until printer is free. Then it will take more wastage of CPU time will be there. So instead of waiting, what the CPU will do is, again CPU will store that first page in a secondary memory. It will take the second page from input device, it will place that second page in secondary memory. It will take third page from the second input data, it will place in the secondary memory. It will place, instead of directly sending each page to the printer, it will place that page in the buffer. Okay, whenever the printer is free, it will take one page from that buffer, it will give the printout. Okay, that's why even though we have given 100 pages, serially each page will be given as the output. That is what is happening in the printer. The printer is using the concept of spooling. It is the best example to understand. What is the best example for the spooling is the printer is the best example. Now, what are the differences between this spooling and buffering? We have to know the differences between this spooling and buffering. In spooling, I/O of one job can be handled along with some operations of another job, while in buffering, only one job is handled at a time. In case of spooling, I/O operations of multiple jobs can be done at the same time. But in case of buffering, only one job can be handled. In case of buffering, only one job will be there. After the job is complete, then only second job will be, it is able to handle the second job. But in case of spooling, I/O operations of multiple jobs can be handled. That is the one main difference. Spooling is more efficient than buffering. Why? Because again the reason is, first point, in case of buffering, it can support execution of only one job at a time, but spooling will support running of multiple jobs at a time. Okay, in buffering, there is a small separate area in the memory known as buffer. In case of buffering, it will take small separate area in the main memory as a buffer, but small part of the memory is taken as a buffer. But in spooling, entire secondary memory is used as a buffer. In case of buffering, only a small part of the secondary memory is used as a buffer, but in case of spooling, entire secondary memory is used as a buffer. Okay, these are the some important differences between the spooling and buffering, and this is totally about the concept of the buffering and spooling. Some two important concepts of the operating system, that is buffering and spooling. Is it clear, guys? What is this one, buffering concept and the spooling concept? I hope this is clear for you now. What is this buffering and spooling? Tomorrow we will see the distributed operating system concept. Okay, we will meet again on tomorrow with the concept of distributed operating system. Thank you very much.